Picture the last seconds inside a 6-story apartment building when the ground lurches sideways at 3 in the morning. You're asleep on the 4th floor. The concrete column on the southeast corner, poured from the exact same mix used in every mid-rise on your block, takes a lateral load it was never designed to absorb. It doesn't bend, it doesn't stretch, it just snaps. The moment that single column goes, the slab above it has nowhere to transfer its weight. The next column picks up the overload, cracks through in under a second, and suddenly 2 floors are falling onto a 3rd. The whole sequence, from the first hairline fracture to total pancake collapse, takes less time than it took you to read this sentence. You never even woke up. That's not a Hollywood dramatization. That is the documented failure mode of conventional reinforced concrete under seismic stress. And it has been burying families alive for the better part of a century. Here is the part that should genuinely disturb you. More than 75% of every earthquake death recorded on this planet isn't caused by the shaking. It's not the fire. It's not the tsunami. It's the building. Specifically, it's the material those buildings are made of. That rigid, brittle, zero tolerance for movement stuff that humanity decided to pour around steel bars and call progress. Concrete is the single most widely used construction material on Earth. And in the middle of an earthquake, it is the single most efficient killer of the people it was supposed to protect. Now, you probably assume engineers are doing everything they can to fix this. You probably think building codes and modern design software are pushing construction toward ultimate safety. And sure, in a narrow technical sense, codes have improved. But what if I told you that the actual fix, the molecular level solution that turns concrete from a death trap into a shock-absorbing sponge, has been sitting in peer-reviewed journals for over 3 decades? What if I told you the active ingredient costs almost nothing, and that recycling yards in your own state will practically beg you to take it off their hands for free? And what if I told you the reason it isn't in the concrete being poured down your street today has absolutely nothing to do with science, and everything to do with a $1.8 trillion industry that simply doesn't make money from buildings that survive? The secret ingredient is ground tire rubber, black powder, crumb rubber from the 1 billion tires the world throws away every single year. Communities beg contractors to haul it off. Your local government pays to stockpile it. In the US alone, we generate over 300 million waste tires annually. That is roughly 1 discarded tire per person, per year, with nowhere to go. But when a tiny percentage of that rubber is blended into a standard concrete mix, the material transforms. It gains something called ductility. That's the engineering term for the ability to deform under stress and hold its shape instead of snapping. It bends where ordinary concrete shatters. It absorbs seismic energy where ordinary concrete just passes the shock wave straight into the next column until the whole structure folds like a house of cards. Think about the sheer insanity of that for a second. The deadliest feature of the deadliest building material on the planet has had a known, tested, replicated cure for 30 years. And the powder that provides it is literally a toxic waste product we can't get rid of fast enough. Fast forward to February 2023, the Kahramanmaraş earthquake in Turkey and Syria. Over 50,000 dead. Post-disaster forensics told the exact same story on a massive scale. Buildings poured with traditional brittle concrete had zero capacity to deform before they broke. They failed in catastrophic numbers. The gap between what engineers have known for decades and what actually gets poured on a job site isn't measured in academic papers. It's measured in body counts. Japan knows this. Chile knows this. Every country sitting on the ring of fire that enforces strict seismic codes has learned through mass burial that making concrete bend is the difference between a building that stands and a building that kills. Chile took a massive magnitude 8.8 event, an earthquake strong enough to be apocalyptic, and walked away with 13 fatalities. 13. Put that same quake under a city built with standard brittle concrete, and you're counting the dead in the tens of thousands. So the question isn't whether the science works. The science is settled. The question is why this material is sitting in tire yards right now instead of in our foundations. Let's do the math that nobody in the construction supply chain wants you to do, because once you run these numbers, you can't unsee them. Walk with me into an engineering lab in the early 1990s. Peer-reviewed testing found that adding crumb rubber to a concrete mix improved its ductile strength by up to 86%. 86%. Impact resistance goes up. The material acts like it has thousands of microscopic shock absorbers baked into it. A 2020 experimental study hammered rubberized concrete columns with the exact back-and-forth shear force an earthquake produces. The rubberized columns dissipated the energy. Standard buildings amplify seismic waves until the connections tear apart. Rubberized buildings absorb the waves and bleed them off as heat. Over 1,000 published studies across 3 decades confirm this. Now, this isn't a startup pitch deck. This isn't some guy's garage experiment. This is accessible data sitting in journals any structural engineer can pull up on their phone right now. So why the silence? Pull back and look at what crumb rubber actually is. It's garbage. You cannot patent a discarded tire. You cannot patent the mechanical process of grinding rubber into a powder. There's no proprietary molecule to protect, no licensing fee to collect, no monthly subscription model to build around it. The construction industry's entire revenue architecture relies on selling you specialized, branded chemical admixtures. They sell superplasticizers and proprietary cementitious materials with aggressive sales teams and quarterly earnings targets. A fix made from landfill trash that communities pay to haul away? That doesn't generate a single line item on anyone's income statement. It solves too much for too little money. In an industry moving trillions of dollars, a solution that costs zero isn't a breakthrough, it's a threat. Every dollar crumb rubber saves a builder is a dollar ripped out of the existing supply chain. And more importantly, a building that survives an earthquake is a building that never needs to be rebuilt. The 2023 Turkey-Syria earthquake destroyed roughly 200,000 buildings. To you and me, that is an unmitigated human tragedy. To the global concrete market, that is 200,000 brand new concrete orders. It's a revenue cycle resetting itself. Buildings that crumble generate replacement contracts. Buildings that hold their ground do not. That is the financial gravity you are swimming against. And while the concrete industry keeps selling us sand at a premium, 1 billion tires are piling up into mountains so large they've become a global crisis. They take 2,000 years to decompose. When left unmanaged, they catch fire and burn for months, dumping heavy metals into the air. They breed mosquitoes. They shed microplastics into our oceans. The disposal problem is staggering, and it's costing you public tax dollars to manage it. Meanwhile, the guy pouring your foundation is buying inferior, brittle aggregate at full retail markup, because his supplier only sells what makes a margin. Now, the industry will try to hit you with a technical caveat. They'll say, wait, adding rubber lowers the compressive strength of the concrete. And they aren't entirely wrong. If you swap 30% of your sand for rubber, the concrete loses structural load capacity. Nobody serious is proposing you build a 50-story skyscraper out of 30% rubber concrete. But the optimal seismic range was never 30%. It's around 5%. At 5% substitution, the ductility gains are massive, and the strength trade-off is basically a rounding error that engineers can easily adjust for. And here's the killer detail the industry leaves out. Researchers figured out years ago that if you treat the crumb rubber with a simple sodium hydroxide solution before mixing it, it roughens the rubber surface, it strips away the oily film and bonds perfectly to the cement paste. Studies show this one little trick recovers almost 25% of any lost compressive strength. So the knowledge exists. The raw material is actively polluting our cities because we have too much of it. The construction industry is actively buying inferior rigidity at full price. And the connection between these two realities has been deliberately ignored because nobody gets a massive year-end bonus for using free dirt. But here is where the wall comes down. Because the actual procedure for doing this is so aggressively simple, the hardest part is believing nobody told you sooner. If you're pouring a foundation, a driveway, or a structural slab in a seismic zone, here is exactly what you do. First, you want a 10 to 20 mesh size for your crumb rubber. That's roughly the consistency of coarse sand. Call almost any tire recycling facility in your state. They sell it by the super sack, dirt cheap. Before it goes near a cement mixer, do this one step. Mix a 10% dilute sodium hydroxide solution in a plastic bucket. Drop the rubber in for 30 minutes. Pull it out, rinse it with a hose, and let it air dry. That's it. 30 minutes in a bucket. That's the secret preparation phase the industry pretends doesn't exist. Next, reduce the sand in your standard concrete recipe by 5% to 10%. Replace that exact volume with your treated rubber. Do not add extra water. If the mix feels stiff, use a standard water-reducing admixture. Pour it, smooth it, cure it just like normal concrete. The finished surface looks practically identical, maybe a slightly lighter tone. Nobody walking past your house will ever know the difference. But the difference lives inside the concrete's molecular structure. Picture a guy named David in Santiago. He poured his foundation 3 years ago using a 10% treated crumb rubber substitution. His house looks exactly like his neighbor's. But when the ground beneath Santiago decides to violently shift again, and it will, his neighbor's foundation will do what brittle concrete always does. It will resist, crack, and potentially drop the house. David's slab will deform. It will absorb the shock. It will give his family the critical seconds that engineering papers have promised for 30 years. I'm not telling you this so you can go wage war on the concrete lobby. That's not how mature industries change anyway. They don't change in boardrooms. They change because the buried information gets out. What you have right now is a specific piece of leverage. Your local home improvement show isn't going to tell you this. Your city code office isn't going to volunteer it. So the move is small. The next time you're talking to a contractor, an architect, or anyone involved in a pour, just ask the question. Ask if they've looked into rubberized concrete mixes for seismic performance. Put the word into a room where it has never been spoken before. If you are building in a seismic zone, look up the mix designs yourself. The material is rotting in a landfill right down the highway, and some manager will probably thank you for hauling it away. The buildings going up today in earthquake zones around the world look completely identical to the ones that pancaked last year. But now you know exactly why. Share this with anyone you know who's about to build something, and stick around, because the next thing the industry hopes you never find out about is already sitting in a stack of journals just waiting to be read.